This will be a short video that parallels an activity that we would do if we were working in the classroom, where I give the students a sheet that has some data about the planets on it. Here's the information. I have the students rank the planets from most to least on these different characteristics: mass, diameter, average density, and so forth. So we can do that here. If we rank them by mass, Jupiter has the most mass by a factor of 3 times as great as Saturn, and you can go on down the list there. Pluto has about 1/27th the mass of Mercury. But if we were to divide this into two groups, which is what I have the students do, I would probably put it right there between Uranus and Earth. That's the biggest jump that happens until you get down to Pluto. You could imagine a second division there, because going from Mercury to Pluto is such a huge jump, a factor of 27. Otherwise, the biggest jump is that factor of 14.5 jump from Uranus down to Earth. And you can kind of split the planets into a couple of categories based on that. If we do it by diameter, it's not quite so obvious as it is with mass, but probably we would still put a dividing line here between Neptune and Earth. That's a factor of 4 difference between those two. And all of the other ones, going from Jupiter to Saturn's not that big a jump diameter wise. Saturn down to Uranus is a factor of a bit more than 2, so that's a fairly big jump. Uranus and Neptune are almost twins, but that Neptune to Earth jump is just about a factor of 4. And then Earth to Venus, they're about twins, about a 2-to-1 drop from Venus down to Mars, and not quite as great as 2-to-1 from Mars to Mercury. Another 2-to-1 jump from Mercury to Pluto, but probably split those top 4 off from the bottom 5. When we look at average density, this time Earth is at the top. It's the most dense planet. Mercury is not far behind, and Venus isn't too far behind either. A little bit of a drop going down to Mars, but then the big jump is going from Mars down to Pluto. It's about a factor of 2 drop almost. And so probably put a dividing line there. Pluto is now lumped with those 4 large planets. Other characteristics, the rotation period in days. These may not be super obvious. The 2 at the bottom are affected by being so close to the sun and to Earth, where their rotation rates are slowed down because of that. If you're going to put a dividing line here, you might put it between Mars and Pluto. It's a little bit hard to tell, and there is a factor of 6 difference between those two as far as the rotation period, but not quite so obvious on this one. The tilt of the orbit of the planets, this is one that's hard to categorize actually. We define Earth's orbit to have 0 tilt and then compare everything to Earth. These are degrees, are the units on here, and the tilt of the orbit. Uranus is almost matching Earth's orbit as far as tilt. Jupiter 1.3 degrees off for its planetary orbit, which isn't much. 1.9 degrees isn't much. None of them are very much, although Mercury at 7 degrees is kind of large, but Pluto's a big jump going from Mercury to Pluto. Pluto's orbit is tilted quite a bit more than any of the other planets. Now, here I'm including Pluto in the planet category, and we know what happened to it. When we look at the orbital periods, we could put a dividing line in between Mars and Jupiter. That's the biggest jump on here, and at least as far as fractions go, Jupiter's orbital period is about 6 times that of Mars, so that's quite a big jump. Otherwise, the fractional jumps aren't all that big. 2 to 1 from Uranus to Neptune, approximately. A bit more than 2 to 1 from Saturn to Uranus, but it's still not as big as that Mars-Jupiter jump. So that's where we would put that dividing line. And then the number of moons. You may not have known about these high numbers of moons. There are a lot of them around Saturn and Jupiter. And for this, one place you might put a dividing line is between Neptune and Pluto, dropping from 14 down to 5. Sometimes people will put the dividing line down between Pluto and Mars, because it's there. Sometimes people will say, well, 2 of the planets have no moons, and so you could categorize them by themselves. But generally, we would put the dividing line either between Neptune and Pluto or between Mars and Pluto. And then one other one, the size of the semi-major axis. This ties in with the orbital period. A fairly big jump from Mars to Jupiter, and that's the biggest jump on there, more than a factor of 3. The rest of them, Jupiter to Saturn just about doubles, Saturn to Uranus doubles, Uranus to Neptune it actually jumps by about 1.5, and then about 1.33 going from Neptune to Pluto. So that's about the way you'd do it. And then the eccentricity of the orbit, I probably wouldn't try to read too much into this one, except that Pluto's orbit is by far the most eccentric. Pluto actually ranges from about 30 astronomical units out to about 50 astronomical units for the size of its orbit. That's the largest range of any of the planets. So we take all of that into account, and we divide the planets into 2 categories. There are the terrestrial planets, which is a term that means Earth-like, and that's Earth, of course, and then Venus, Mars, and Mercury. And then there are the Jovian planets, Jupiter-like planets, Jupiter, Saturn, Uranus, and Neptune. That's the way we have the planets divided. We've got some subdivisions in there. Uranus and Neptune are actually split off as kind of ice giants, but we'll look at those in another video.